Hey class, Miss Anderson here. We're going to do simplifying complex fractions. To start, I have a review problem with adding and subtracting. So with adding and subtracting fractions specifically, remember that your denominator has to be the same. So if we're finding a common denominator between x minus 3 and x plus 7, we're thinking of these as a factor together. And so this side is missing an x minus 3, and this side then would be missing an x plus 7. So that would make the denominators the same. But in order to keep our fractions equal or equivalent, we need to multiply by a factor of 1. So if we multiply this side, the denominator, by x minus 3, we have to multiply the numerator by x minus 3 as well. And same over here, if we multiply by x plus 7 in the denominator, we need to multiply by x plus 7 in the numerator as well. So now we're multiplying by a factor of 1. We're keeping the value of the fraction equal, but we are making the denominators the same. Since we have a monomial term times a binomial term, we do need to distribute that 2. So you're going to get 2x plus 14. And I'm not going to multiply the fraction or the denominator out yet. I'm just going to leave it as x plus 7 times x minus 3. And then we have minus, and then same thing over here. You have a monomial term times a binomial, so you will have to distribute. So 1x minus 3 all over x plus 7, x minus 3. Okay, and then another thing to be careful of is when you are subtracting now, the denominators are the same, so we can go ahead and combine our numerators. But we are subtracting, and we're subtracting a monomial piece. So remember when we subtracted with polynomial functions before, so we can subtract the numerators and then the denominator stays the same. When you subtract, you have to subtract both pieces. Or we can think of this as adding and then do the opposite. So we distribute in that negative sign. So we want to make sure when we have anything more than a monomial term we're subtracting, that we subtract every term in that polynomial. So then combining like terms in our numerator, we would have 2x plus negative x, or negative 1x would be 1x, and then 14 plus 3 is 17. And then all over x plus 7 and x minus 3. And I kept the denominator factored because it is a chance that the numerator could have simplified to x plus 7 or x minus 3, in which case I would have been able to simplify. But, oops, I'm not able to simplify, and we want our answer written in standard form, so we have x plus 7, and then multiplying this out would be x squared minus 3x plus 7x minus 21. So we get x plus 17 over x squared plus 4x minus 21. Okay, so today we're going to be learning about complex fractions. And complex fractions are when we have a fraction in the numerator and or a fraction in the denominator as well. We have two methods of solving. Our first method is simplifying the numerator and the denominator into one fraction each and then multiplying by the reciprocal. So when we divide fractions, our rule is to multiply instead by the reciprocal. So here's an example of that. And this works nicely when you have like a single fraction divided by another single fraction. It's top time or divided by the bottom, so then you would take the top times the reciprocal of the bottom, and then you can simplify from there. But it only works nicely when it's set up like this. If you have multiple fractions, so like you have a fraction minus a fraction in the numerator divided by two fractions being subtracted in the denominator, then the method that works a little bit easier is to just multiply the numerator and denominator by the lowest common denominator of all four fractions. And so in this example, you have the denominators of x, 3x, x, 6x, and so your lowest common denominator is 6x. And multiplying everything by that 6x reduces this down, and then you're able to simplify. So I'll show you some examples that involve both. So in this case, I have the top, which I'm going to rewrite, is x squared minus 4 over x, and it's being divided by x plus 2 over x. And so in this case, I have a fraction divided by another fraction, in which the first method, I think, in my opinion, would work a little bit nicer. You can multiply then by the reciprocal. So we'd keep the first fraction the same. It's the keep, change to multiply, flip the second one idea. And so now you're just multiplying fractions like we've done previously in this unit. And so when you multiply straight across. So you would have x times x squared minus 4 over x times x plus 2. Now we have a common factor of x, and x divided by x simplifies to 1. And then you can finish factoring the top. We have difference of perfect squares. So we'd get an x plus 2 times an x minus 2 over an x plus 2. And we have a common factor, again, of x plus 2 divided by x plus 2. And anything divided by itself simplifies to 1. So we end up with x minus 2 over 1, which simplifies to just x minus 2. And that would be our final answer for this problem. This example is going to be very similar to the last one, so I'm going to skip that for now. Here we have a combination of fractions. On the top we have a difference of two fractions, and the bottom we have a sum of two fractions. I'm actually going to make the middle line, this is my division between the top and the bottom, so I'm going to make that a little bit darker here so you can see it. So in this case, in order to apply the keep, change, flip, or the multiply by the reciprocal, you would have to combine this difference and this sum first. So to avoid that step, I'm going to look at the common denominator between all four of my denominators. So between 2x, 3y, 3x, and 2y. And so first, the common denominator between 2 and 3, if you count by 2's and you count by 3's, you'll see the first thing that they have in common is a 6. So 6 is going to be my common coefficient. And then for the variable piece, I need an x and a y. So I would multiply this by 6xy and this by 6xy. And so when you're thinking about as a whole fraction with the big, like this whole fraction, we're still multiplying the numerator and the denominator by the same thing. So you're multiplying it by a factor of 1. So you're not changing the value of the fraction itself. And then when you're multiplying a monomial by binomial terms, you're making sure to distribute to each term. And you're multiplying on the top, 6xy is really over 1. And so we're multiplying to the numerator here. So you're going to get 6xy over 2x minus 6xy over 3y. And then in the denominator, distributing that too, you're going to take this, remember this is really over 1, so you're multiplying the numerators and then multiplying the denominators. So 6xy times 2 is going to be 12xy over 1 times 3x is 3x, plus 6xy times 5 is going to be 30xy, and then 6xy times 2y, oops, I forgot. Never mind. It's going to be 1 times 2y is 2y. And then simplifying each piece individually. So looking at this piece first, they have a common factor of 2. So I can divide out a 2 and I can divide out an x. And so that's going to leave me with just a 3y over 1, which is 3y. And then over here, it has a common factor of 3 because 6 is 3 times 2. So I can get rid of, or I can simplify the 3 and I can simplify the y's. And so that leaves me with a minus 2x. And then I have my main fraction line. And then simplifying here, they have a common factor of 3. 3 times 4 is 12, so I can divide out a 3. They have a common factor of x. I can divide out an x. That's going to leave me with a 4y over 1, so just 4y, plus this one, they have a common factor of 2. 2 and 15 make 30, so I can divide out a 2, and they have a common factor of y, so I'm left with a 15x. And then I have just a single fraction, and I'm not able to simplify any further. These two terms do not have a common factor, nothing that I can divide out of each of these. They don't have anything in common in the denominator, and this is not the same as this, and so that's as far as we can simplify for that one. Okay, let's try one like this. So I'm going to make this one a little bit darker here again. This is our main fraction, so we can see the difference between our numerator and our denominator. And then looking at the individual fractions, and the numerator has a denominator of x minus 4. In the denominator, we have an x minus 4 and an x plus 1. So our common denominator is going to need both of these factors. And so we're going to need an x minus 4 and an x plus 1 for these to all have a common denominator. So I'm going to do the method of multiplying by the common denominator. So I'm going to take the top times the common denominator of x minus 4 and x plus 1. And I'm going to take the denominator times that same x minus 4 and x plus 1. So if I think about my big fraction here, I am multiplying by a factor of 1, the same thing in the numerator and denominator, so I'm not changing the value of the original fraction. But then if I zero in on just the numerator, remembering that this is a term over 1, and so when I multiply this, I would multiply the numerators together and the denominators together and make one big fraction, in which case my x minus 4 divided by x minus 4 would simplify to 1, and I would have a 3 times x plus 1 left over 1. So done there, divided by. And then I'm going to want to multiply this to each here, so this one here and this one here. I might want to rewrite it on this side, but I just wanted to be clear, I'm not multiplying it 3 different ways. I'm using the distributive property over here. This is over 1. So then combining these fractions together, I can simplify the x minus 4 divided by the x minus 4. That simplifies to 1. And I'm left with a 1 times an x plus 1. And then I have a plus here in the middle. And then simplifying over here, these together, I have x plus 1s divided by an x plus 1. That'll simplify to 1. And then I have left a 3 times an x minus 4 over 1. And then I want to simplify this more if possible. So I'm going to leave the top factored for now. And then the bottom, I'm going to multiply it out so that I can combine like terms since I have a plus sign. So distributing here, 1x plus 1. Distributing a positive 3, it would be plus 3x minus 12. Combining like terms in the denominator would be 4x minus 11. Now I left the numerator factored just in case I was able to factor the denominator more, in which case I might be able to simplify. I am not able to factor the denominator more, so I want to put the top into standard form. So I got 3x plus 3 over 4x minus 11. And that would be my final answer. Got a little messy. Sorry about that. All right, we're going to do one more, maybe 2 more, depending on how much time I have here before the bell rings for flex. Okay, so for this one, I noticed that I have my big fraction bar is right here, And then I have my numerator, the denominator is 2x plus 4, and the denominator I have these two. Now what I noticed about the denominators in the top right away is that they are factorable, and that's going to help me find my common denominator, is to make sure that they are in factored form first. So in my numerator, I can factor out a 2 from the denominator, so that would look like this: 2 times x plus 2. Remember, factoring is the reverse of multiplying, so you can multiply that back through. And then over, and then 5. On this side, I can factor out a 3, x plus 2, and then plus 3 times x plus 2. So now I can see that they have a common factor of x plus 2, so that's definitely going to be in my common denominator. But then I also look at my coefficients, 1, 2, 3, and that means that I'm going to need a common denominator between 1, 2, and 3, and that's going to be 6. So my common denominator is going to be 6 times x plus 2. So I'm going to multiply the numerator and the denominator by 6x plus 2. And I'm going to multiply down here as well. So I'm multiplying both the top and bottom of the complex fraction by the same thing. And then on the top, remembering that I'm going to move this just a little bit closer. And then remembering that it's over 1, so then I can combine these. They then have a common factor of x plus 2. And then I am left with just 6 over 2, which simplifies to 3. Then here, I need to distribute this to both. So on this side, when I multiply by 6 times x plus 2, I'm going to be able to simplify the x plus 2's, and I'm going to be left with 6 times 5, which is 30, divided by 3, which is 10. And then this side, we're going to divide out the x plus 2's, and remembering that's over 1, I'm going to be left with just 6 times 3, which is 18. And then combining like terms, I'm going to get 3 over 28. Is 3 divisible by 28? 8. This adds up to 10, so no. Okay, so that's my final answer. You can hear the announcements in the video probably. That means we are time for flex. So I'm going to have to pause this video here. Hopefully I've done enough examples. In this one, you would want to do the common denominator. You need a common denominator between those 4. And you're going to need a 2x and an x plus 3 because those are separate factors that are uniquely different. So a common denominator would have to include both of those, and then multiplying all 4 fractions within the big fraction by that will get rid of the fractions. So give it a try and then check back on the completed notes or ask in class if you need to. All right, time's up.